Okay, so we are going to create a steady rest for operation inside of Esprit TNG. So if you have a steady rest solid model, step file, any type of engineering drawn solid model assembly, you're going to want each of the arms to be, separate individual solids. Otherwise, those would have to be split. But let's go ahead and get started. Okay, so this is the product. It is a SMW Autoblock file. You can see the steady rest assembly. The solid model here in the center, I'm assuming this is going to be the maximum and minimum, maybe the maximum and minimum dimensions that this can, clamp onto. So starting out with this solid, the first thing that we wish to do is to orient it correctly for the machine. So when I look at this, typically we are going to be, if we were standing in front of the machine, it would look something like this if we had a slant bed lathe, where the z-axis would be coming out of the main spindle, and then the x-axis would be pointing up, into the turret. If we had, a standard smaller lathe or so, it would be like this. So looking at the solid model for this SMW Autoblock, it's basically 180 degrees from the orientation that it needs to be, because this would be upside down. I mean, we're not going to have a steady rest mounted on the top of the machine. This needs to be basically mounted, at the floor. So what I need to do, if I rotated this about the z-axis, that would put the top of this component, so you could see here, this is the top of the component that would likely be for servicing. What I want to do is actually flip this 180 degrees about the y-axis. So let's go ahead and do that. What I can do here is just hit Control A on my keyboard, or right click and say select all. That will grab everything on the screen. And you can unselect these solids. It doesn't really matter because they're going to stay on the z-axis. I'm going to right click and say copy and say rotate, move, not 90, 180. And I'm going to uncheck use origin for rotation axis, and I'm going to pick, once I say okay, I'm going to pick the y-axis. Give that a second, and then we should have this properly oriented. So now maybe it's a little bit easier to kind of see. If I was standing in front of the machine, my x-axis would be going up into, the turret. So if this was my workpiece right here, with my spindle on the left and the negative z side, this is how I would want the steady rest to be. If it was a slant bed lathe, it would be mounted, something like this, about 30 degrees. So we are ready to go ahead and create the GDML. However, I'm going to just take a quick break here on the coloring. This is all gray, which, maybe that's fine for you. If you did want to change some colors, I'm going to go over that really quick here. We can select a solid model on the screen. So let's say, you want to make this look nice, or make it look like your component that you have on the machine. So let's say this main housing or body of the component is maybe a darker metal. It's got a coating, anodized or something. So what we can do is grab those two solids, and under properties we can come and select maybe a darker shade of gray, whatever. You can slide this up and down inside of the Windows custom coloring functions here. So you can set it to whatever you want. If this is a little bit dark, not a big deal. You can select those solids again, come over and pick maybe something a little bit lighter. Another thing that you can do is inside of the selection filters here. So you have the if you're not able to select a solid model, you probably have your solid bodies unhighlighted. So here you can see all the bodies. You want to make sure that you can pick the solid model by having, if you just click outside of this box here, you know, a couple times, you can highlight everything. But this second icon down here is going to be your filter. And here, what we're going to do is for the loop, we're going to try and use closed pocket cavity. And for example, if I want to make the logo a little bit darker, I can just pick this face here. Oh, sorry, not the loop, I mean the face. So what we're going to do here is pick this face, and you can see that when I hold my shift key down, if I don't hold the shift key, I'm going to get the face. But if I hold my shift key down and pick the face, I'm going to get everything that's basically a closed pocket loop inside that face. And then I can hold the control key down and basically, you know, turn on or turn off any of these additional faces that I want as part of the group. So now if I want to make the logo pop, I can come to an attribute for the faces by right-clicking and going to copy, and then maybe changing this to, you know, a darker black or something like that. And when I do that, then I can really see it. So if you want to go through and change colors and make it look a little bit nicer, you know, you only make a GDML once. So it only takes a few extra moments to do that. And sometimes you get solid models from OEMs and they're green and they're orange and yellow. So you might want to know how to do those things. So those are a couple of quick tips on how to make this look a little bit nicer. So now what we're going to do is we're going to go ahead and start creating some of our axes that we need for creating the GDML itself. So this is similar to a 3-jaw chuck, and if you've gone through that, then this is going to be somewhat familiar to you. So looking at each of these, you know, you've got basically 3 arms. You've got the 2 on the side, and these actually rotate about a center point, you know, maybe right here and here. And then you have this one in the center that is going to come out and support the workpiece in the center. And we're going to use a JA or jaw adapter inside of the TNG interface to get started. We'll have to edit this inside of Machine Tool Builder, but what I'm going to do is just create 3 jaw adapters quickly so that we can take this, save it out, and then go into Machine Tool Builder. So I'm just going to come here and say JA_1, JA_2, and then add another one, JA_3. And that's going to be it for now. So what we're going to do now is just save this. We'll go to File, Save As, and then I'm going to come here to a folder. Do I have SMW Auto Block here? No, I don't. I'm going to go ahead and create a quick folder, and then we're going to save this as a fixture type of file, a fixture GDML file, and we'll call this, I have the file name over here. I'm going to go ahead and just copy and highlight this and then bring it back over here and say save. Okay, so now we're ready to bring this into Machine Tool Builder. And what I did here was I created the complete steady rest, and I have the original so that we can take a look at what we need to do and have them both open as reference. So as you're following along here, the original is going to be in this right tab. It says ORIG, and the final product is here. So this is the way it's going to look when you bring it in. You're going to have this hierarchy. And honestly, I don't really remember what windows are open when the first time you ever open Machine Tool Builder, because that was a couple of years ago for me. So you can come to view here, and you can you'll need to turn on the axis list. So you definitely want to do that. But you want to basically turn on and off the overview, the properties, and the axis list. So make sure that you have all of those. I have the output window, which when you're saving GDML, sometimes there's an error with a component. It's helpful to have open. But let's have this all open. So go ahead and pause and get it ready, and then come back and hit play again. So this is the way that it's going to look when you first open the GDML inside of Machine Tool Builder. And in Machine Tool Builder, when you left click, that is going to rotate. Okay? When you left click, that is going to rotate. As opposed to in TNG, where you have to hold the control and middle mouse button. To pan, you want to hold the left and right mouse button at the same time. And then to zoom in or out, you could just use the wheel. So when you zoom in and you need to pan, you can hit the left and right at the same time. And then, rotate is going to be just clicking with the left and rotating. So we have this. We want to wind up with this. So let's go ahead and start. When you create the JA1, 2, and 3, here they are, and then Esprit TNG in that interface, you're going to automatically get a default for the workpiece adapter and fixture adapter, and you don't need these. So we can just delete these. Those can be gone. And something that I actually neglected to mention when we were inside the TNG interface is obviously the Z-axis should be centered around the center of the clamping unit here. So you want to make sure that when you're in TNG, that when you orient and position this, that that it's centered around the Z, or at XY0, centered around the Z-axis. So then we're going to have these 3 linear axes here. But as I was mentioning before, you have the 2 arms there. These 2 arms are going to rotate about a point here. So what we want to do is actually, it doesn't really matter which one of these you want to utilize for each one. So let's go ahead and just for nomenclature I don't know if I did this on the first one. I did not. But what we're going to do is come here, and you can click on that, or you can come in here if this is easier, and we can say this is going to be the left, or we'll call this the top arm, and then this one we'll highlight, and then come here, and we'll call this the bottom arm, and then this one we'll call it the center, okay, or center arm, or whatever. So this is just going to kind of help us organize in our mind as we're looking at the list and not get confused. So for the arms, we don't want, you can see here that this is an arrow, and this is a linear type of movement that we don't want. We want this to be a rotary movement. So what we're going to do here is I'm going to come and just right click and say delete, or you can hit the delete key. I'm going to right click and hit delete again on that one. And then we're going to leave this one where it is, because we do want the center arm to be a linear movement. So this is going to move linearly toward the part and away from the part. Okay, so the top arm, we're going to right click on that, and we're going to say insert an item, and we're going to come and select rotational axis right here. And once we do that, we're going to get a new axis list with, and you can see that this is like a rotary, a round arrow. We're going to do the same thing on this one here. We're going to do another rotational axis. And now what we want to do is figure out where these axes are going to rotate about. So inside of TNG, and you could do this in the TNG interface here, you could come here and pick the center of a face or a cylindrical, you can make a geometry point there. Maybe this is a little bit easier to illustrate. I'll just snap a point here. And once we have that point and I highlight it, it's going to give me the dimensional, coordinates for the location of that point. However, the Machine Tool Builder interface, running in metric, I'll have to convert this and type them in and stuff. So what we can do is kind of zoom in on this, and we can come over here to this last icon that looks like a right angle, and we can say toggle the measuring mode on, and then as I move my mouse, you'll see that it will digitize different stuff on the screen. I can get little endpoints, center points, and stuff like that, but I want to make sure that I'm zoomed in on the cylinder right here, the circular face, and that when I put my cursor over that, I have that center point. And when I do that, it's going to give me the location of that center is minus 93, 85, and 47. So on the axis itself, we're going to want to put those values into the center of the axis. So we're going to want to put in minus 93, 85, and then 47. And it says the axis direction. So for the z vector, we are going to be rotating about z, and we could leave that alone for now. And you can see here on the completed that we have, you don't need to put in the z value, I guess, because it doesn't really matter. But you could put in 47, or I guess you could put it at 0. Doesn't really matter. And then what we want to do is do the same thing on the other one. So I'm just going to pan everything up a little bit and zoom in, and then I'm just going to go ahead and pick on that. And you can see here that we have basically the same coordinate values for the x and the y, except the y is, of course, a negative of the other side. So this one is going to be minus 93 and minus 85. So we're going to come over here and say minus 93, minus 85, comma 0, and hit enter. And we can toggle the measurement mode off. So we're going to come here, and we want to have a representation of the way that this is going to move inside of Esprit TNG. So your solids, there's a lot of solids on this file, and we want to put each of the arms on a respective node that is going to represent all of the solids for, let's say, the top arm, the bottom arm, and then the center arm, and then leave the main body under the main node, which is here. So there's a lot of solids here. This one that I'm using is quite complex. So what we're going to do here, just to save on some time, because whoever's viewing this, I'm not sure how many solids you have. You probably don't want to sit here for 10 minutes as I evaluate which solid is which. So what I'm going to do here is just show you what you need to do to put those solids where they need to be. Underneath each of these rotational axes and linear axes, we're going to right click and insert another item, and we're going to insert another node for a group, and we're going to do this on all three. So right click, go to insert item, and go to group. And now on each of these groups, we want to find the model that is, or the solids that are going to be part of that group. So again, just quickly here, this one, you can see when Esprit Machine Tool Builder is viewing a singular solid, it's going to make all of the other solids transparent, and it's going to highlight or solid shade only the solid that you're selecting. So an easy thing to kind of scroll through these, because these first three that we're looking at are going to stay on the base. They're part of the main housing or unit. So what I'm going to do here is just use my down arrow on the keyboard and just kind of keep going through each of these solids. And this one can stay on the main base here as well. As we go through these, I see some bolts, etc. And we haven't come across anything yet. So here's one. Okay, so solid number 31. This solid 31 is going to be part of the lower arm, or the bottom arm. So what we can do is just remember 31, and then I see the next one here is this plate. So we're just going to go ahead and grab 31, and I'm going to hit Control C and Control X, and then come down here, and we're going to go to bottom arm, and then right click on that node for that group and say paste. And now you can see that the arm is, that solid for the arm has been moved to the node for the bottom arm, and it's no longer in the list here. So in the list, we're now, because I did a cut and paste, we're going from 30 directly to 32. And you would continue to do this throughout all of the solids. So here's the top arm, which is 42, and I'm not going to do that. We're going to go ahead and switch over to this one, just so that it isn't going to take so much time. So we have those nodes that have been created, and here's the solids. So each one has about 10 solids, but you have to find them. And here's the next node for the right arm, just to show you. And then here we have the center arm for all the solids that are associated to that center arm. So going back to the original, we have these three sorted already. Going back to the original here, let me go ahead and minimize this node. And you have this that you can delete from the original. So that is the main thing, is to move everything at this point to their respective nodes. Okay? And then what we want to do is just make a couple of tweaks to some of the values that are going to represent how this GDML is going to behave inside of the Esprit TNG simulation. So under the main, kind of designation here, what we want to do is change the clamping type. Okay, so when this comes in, it's going to be set to clamp, because fixtures by default, they come in set to clamp. And what we want to do is just, expand this with the down arrow and then double click hold to make sure that that is set to hold. So that's the first change that you want to make. Then what we want to do is put in some limits to the movement of the components themselves. So we have three components that are going to move here. It's going to be the two arms and that center arm. So the first thing is probably coming to the rotational, and we see here that this is set to the center about a positive Z direction, so 0, 0, 1. And then what we want to do is determine what our upper and lower limits are going to be. And you have these models still inside of the original. So you can position these a little bit beyond if you wanted to, if you want to calculate that angle, or if the specifications of the steady rest tell you what that is, that's great. I used 0 and 35 degrees for mine, and you'll notice as well, just really quick, this original, I deleted that cover, because the way that it was modeled inside the original, this should be rotated back if you wanted to, where these kind of set screws or holding screws are, but it was interfering with the bar stock. So what I did is I basically just deleted those, and that's just a process of going in here and figuring out which one is that solid, and then just deleting it. So those are the main changes here. So let's go through them really quick. So here you can see the lower limit is -35 and 0. And you can test out your lower limits, because once you've got them, you can see here on the axis list, I can scroll my, this is the upper arm. I could scroll my upper arm from the minimum to the maximum. So the lower limit is -35, and that's going to be by closed setting. Okay, so here we're at -35, and then 0 is basically where the arm in the default CAD position coming in from the OEM solid was located. So, and to change these, you just click in here and you put in whatever value you want. So I could put in -60, for example, and that's going to make this obviously close far beyond where I want it to be. So I'll just change that back to -35. So you're going to have that these limits set to your positive or your upper and your lower angles for open and close. And you're going to do the same thing for this axis. But since this one, I like consistency, so I wanted to use the same numbers. And what I did for that is I just put a negative in front of the 1 here for the axis direction. So this is very important. I'm going to leave that highlighted in case you're kind of skipping through the video a little bit, as I do with stuff. So I'll leave that highlighted just to show, hey, how's this -35? And then you have to put in a negative here so that these will match up. So if I test that as well, we're going to get the same open and closed movement for the upper and the lower arm. And then for the linear, where do you want this to go? And again, you can take that measurement inside of the TNG interface. It's much easier to do that between the two solids, or you can do a subtraction, with the diameter of the bar, the small and the big bar. But what I did is for this one, I eyeballed it to 0 to 75 because the Esprit TNG simulation is going to go up to the workpiece diameter, and then it's going to stop anyway. So you just want to make sure that it's a little bit beyond, unless you wanted the system to maybe error out that it was beyond the limits of the GDML. So here we have 0 to 75, and if we come to this axis here, we see 0 to 75. So I'm basically doing the same thing. I'm putting the lower limit of 0, the upper limit of 75. How do I know it's an upper limit? Because here, instead of 0, 0, 1, I have 1, 0, 0, and that's because we're moving along the x-axis. Very important. You have to change this to 1, 0, 0, and we're moving positive. So you can see the direction of the red x-axis arrow here, and this is going to move in a positive movement. So the lower limit is going to be the 0, and the upper limit is going to be the 75. So once again, we can scroll this and see where that goes, and we're there. And then on the axes themselves, so on the JA center arm, you're going to want to set these. So here we're going to have the closed position is going to be 75. That is giving Esprit's simulation the limit for where it needs to go. So it's going to go from 0 to 75, and that's it. And then on these rotary, you're basically duplicating the same thing, 0 to 35 and 0 to 35. And once you have those limits set, then you could resave the the GDML, and then you should be able to use it successfully inside of your Esprit file. So hopefully this helps you create a working GDML file for your steady rest. If you have any questions or if something went wrong, you can send your GDML to the support team at support@dptechnology.com, and we can take a look at it and help you out.